As you noticed in the last video that you watched, we did all the same things that we have taught so far. Sum and product of the roots, being able to check your roots, and being able to write a quadratic equation, multiplying things out, all of those things, but with irrational and imaginary roots. Well, today we're going to take it another step. You recall we learned how to graph parabolas. We worked quite a bit on how to graph a parabola. But those all entailed ones that had rational roots, ones in which actually crossed that x-axis. Well, today's plan is we're going to graph quadratics, but with imaginary roots. This obviously poses its own little issue. So what do you do with that? What do you do when you have something that has imaginary roots? So what are those steps that we took to graph a parabola with the rational roots? But what are those 3 steps? Now, we had it actually in 4, but I'm going to kind of group one together because hopefully you remember those 4 steps, yes, as you work through this. But if we were to group them together, the first step is always to find the intercepts. And yes, we broke that into 2 different steps, so that's why it was 4 before. The second step is to, excellent, the turning point. And the third, of course, is graph it. So now knowing that, let's go through these steps. Same idea, but now knowing that they're going to look a little different. Obviously still U-shaped, but there's going to be a little change about them. So we have x squared plus 3x plus 9. So our first job, find the y-intercept. The y-intercept is what? It is always when x equals 0, and this is usually the constant. So let's do that. In this case, it's going to be 9. Okay? The x-intercept. This is when y equals 0. And this usually requires some kind of solving or factoring. So let's do just that. I don't have an orange color, so we're going to have to use our purple here. But so that means I'm going to put 0 in for y. And we're going to try and factor. Now, if you think about factoring it, we've got 3 times 3 gives me 9. That will not add to give you 3. So what do we have left? 1 and 9. That also isn't going to work. So when I solve this, I get x equals negative b, right? Plus or minus the square root of b squared. Can we do that in our head? Minus 4 times a times c. All over 2a. And so just to quickly kind of simplify this, you have 9 minus 36. And what exactly is that? Negative 25. Good. So what does that look like then? We have negative 3 plus or minus. What is that negative under the radical going to do? Make it imaginary. And so what does that look like? What that basically is saying is when we're looking at that graph, our graph is rational. Those numbers on that number line are your rational, irrational numbers. But it does not allow for these complex numbers. What that basically is saying, it's imaginary. It's not going to cross your real number plane. And we'll get into what that looks like here in a second. The beautiful part about the turning point here, and maybe you haven't observed this beautiful piece, but remember when we learned about the turning point, it's negative b over 2a, or it's halfway between the roots. Well, when you're looking at the roots and you're saying, okay, negative 3 plus or minus 5i over 2, it might be hard for you to see this, but the truth is you already did x equals negative b, all over 2a. Right there in front of you is the turning point and has been all along. Remember, you have your turning point in your parabola, right? And it's at that pivotal spot. And this is saying, okay, you're going to move to the right 5i and to the left 5i, and that's where it's going to cross. Or if that was a real number, it'd be plus 5 and minus 5, and that would allow you to see where it would cross on the x-axis from that pivotal spot, the turning point. So knowing this, it's not going to cause us to do any more work. We already have that turning point x value, which is negative 3 halves. And so we have to find that y value. If you recall, finding that y value requires you to use that original equation, and so we're going to have to do that. This does take some work for sure. So y equals negative 3 halves squared plus 3 times negative 3 halves plus 9. So squaring that, that's 9/4. And I have minus 9 halves plus 9. It helps obviously having a common denominator, which would of course be 4, or using just your own abilities with fractions. If you know that you have half a piece and you take away a quarter of it, what does that look like? I don't know if you're good at these. For example, what I'm looking at here is this 9 halves and the 9/4. When the numerators are the same, there are some tricks to that as well. Certainly seek those out. But that actually is going to be negative 9/4 plus, and I'm going to convert that to be 36/4. So that gives me 25/4, and that is your y value that you have there. Awesome. Okay, you might think, how in the world is this going to help me? Well, let's graph this, because that's the next step. We know that it crosses the y-axis at 9. So I've got that. We also know the turning point, as vague as that may seem. And remember, since we're just sketching, it's not like I have to have this on a grid and be very particular. I've got negative 3 halves, so that's over here someplace, and 25/4. Keep in mind where that would be in perspective of that 9. If you divide 4 into that, that's about 6, 6 1/4 to be more exact. So if this is where 9 is up here, then 6 is going to be just below that. So we'll kind of put it there. That's 25/4. We know it's positive, so we know it's up. And truthfully, the intercepts don't help us because you can see this opens upward with a positive x squared. Okay, so we know it opens upward. So all we're going to do then is, we know this is the turning point. So start there, and it's got to go up. It's got to pass through the 9. So up it goes. And the other side's just going to be symmetric on the other side. Hopefully that's clear enough for you. Okay, there's going to be some more examples here. I want to at least try to get one more in. And so I'm going to clear the page here. Okay, let's see if we can do this relatively quickly. All right, we've got the y-intercept. Done. Easy enough. The x-intercept. Well, if you think about this and solving this, I'm actually going to even rewrite this so that it's x squared equals negative 4. Hopefully you can, by now, we've done enough practice with this, you can see this is going to be imaginary. All right, so now I've got the turning point. The turning point, remember, negative b over 2a. Well, all right, negative b. What is b? 0 over 2a. Well, 0 divided by anything is 0. So I don't really care that it's over 2. It is just 0. If I plug 0 in, I get the point 0,4. This is probably one of the easiest ones to graph. All right, so what do you think? I only got 1 point. You're right, but it's the turning point, 0,4. Which way does it open, up or down? Opens up. And there you have it. There's the second example for you. We'll be doing more of these in class as the days progress. Hopefully this video has been informative for you in terms of graphing with imaginary roots. Good luck.